Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be discussing tonight will be the actual operation of this car relay. This is the car relay. Okay, the markings are actually on the body. Okay, it shows the normally open load and the normally closed load plus the coil. Okay, so these are actually the markings. Number 30 is the one at the bottom. Yeah, number 30 is the one at the bottom. So this is the actual connection of the relay. Number 30 should be injected with the voltage source. 86 is the ground. 85 is the trigger. Terminal number 87, there's a load connected to it. And the contact with it is actually normally open. Terminal number 87A is the one at the middle. There's a load connected to it. And the contacts which connect this load to 87A, it's normally closed. So meaning to say, when we try to activate the relay, this normally closed contact will open and this normally open contact will close. Okay? I will repeat it. Terminal number 86 is the ground. So, for both load number 1 and number 2, they got grounds. And their ground is supposed to be connected on terminal number 86. For the power source, there's also a ground. This is the ground. So, all those marked where ground are actually common. This is ground. This should be connected to this ground here. This should be connected to this. And so with this one. And terminal number 85 is actually, there's a marking here. I place it here, B+. It is the so-called trigger voltage. Trigger voltage meaning to activate this relay, for the loads to be activated, we should trigger the relay at terminal number 85. We should inject a B+ here. And this B+ here should be the same as the B+ coming from the battery or any regulated power supply that we will be using. So I made the connection now. So instead of using the battery, I got my regulated power supply here. So this is the plus terminal. This is the negative terminal. The plus terminal is connected at the bottom portion. So this is white. Coming from the plus, it goes to terminal number 30. Terminal number 30 over here. Terminal number 30 should be injected with the plus 30 volts. And the ground connection, this is the black. It is connected to terminal number 86, the one on the left. Okay? For load number 1, the one that's connected to 87A, it got a ground. So this is the ground for load number 1. I connected it. And the positive terminal of load number 1 is actually 87A, the one at the middle. This one, the one in red. That's the one on the middle. So as you could see it, I applied 12 volts on the power supply, and load number 1 got a voltage already of 11.94 volts. How come it got 11.94? It got 11.94 because the contacts connected with load number 1 is normally closed. Okay? For the second load should be connected to terminal 87 and ground. And what I did is that I put what you call this, a load. This is the load. I got a buzzer here, okay? So I put its ground on terminal number 85. This is the buzzer, and the positive terminal should be connected to 87. 87, the one on top. 87, this one. Okay? The buzzer is not yet working. Why? Because the contacts connected to that buzzer for load number 2 is normally open. So how do we know if this buzzer here is working or not? Okay, it will just be a matter of triggering the relay. To activate the relay for the contacts to change positions, meaning the normally closed will open and the normally open will close, we should apply a trigger voltage. This trigger voltage here emanates from the voltage power source on number 30. So it is still the same 12 volts, this one. So if I will try to trigger the relay, I should touch this one to the positive, or to the terminal number 85. Terminal number 85. This one, the one in red. This one, the one at the middle, far right, this one. If I try to connect this positive voltage of 12 volts to this number 85, we should activate the relay, okay? And the normally closed contact will open and the normally open contact will close. So when the relay is activated, this voltage will become 0 and the buzzer should sound, because this is load number 2 and this is load number 1. Load number 1, I don't have any load yet, but just to show you that there's a load, the voltage is 11.94. Okay, let's try to activate the relay. So I will try to trigger the relay by connecting the voltage source coming from 30 to terminal number 85. Okay? As you have noticed it, when I trigger the relay, this voltage becomes 0 and the buzzer operates. The buzzer operates because when the trigger is relay, its contacts will close, so the load supposed to be will be activated. And how do we know it activated? It sounds, right? And for the first load, it was deactivated. Why? Because the voltage, when we trigger the relay, the voltage will become 0. Okay, I will repeat it one more time. I will trigger the relay. I will touch the 12 volts to the terminal number 85. Voltage 0, the buzzer operates. Okay? Again, I will repeat it. When I trigger the relay, this voltage becomes 0. It was deactivated. It was deactivated because its contacts were normally closed. So when the relay is energized or triggered, the contacts will open. So supposed to be this 11.98 becomes 0. And for the second load, and since its contact is actually normally open, when the relay is activated or triggered, the contacts will close, so the buzzer sounds. Okay, I'll repeat it one more time. That's it. So this is how this relay operates. Once we trigger, the first load will be deactivated and the second load will be activated. First load is deactivated because its contact is normally closed. Second load is activated because its contact is normally open. So when we trigger the relay, it should sound. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes. This is the actual operation of a relay. Good evening.